Alright, welcome back class. Section 5.1 we covered properties of exponents plus scientific notation. Today, again, you could practice these problems, warm-up problems, there's 4 of them, just to see if you mastered the skills. If not, then again, I'm going to have a little activity tomorrow in class. But moving on, today we're actually going to get into the meat and grit of Chapter 5, which is graphing polynomials. Alright, so again, by the title, you are going to be able to evaluate and graph polynomial functions. Actually, today we're just going to be evaluating polynomial functions. If we get to the graphing, great. If not, then we'll watch it for tomorrow's homework. And then the next day we'll come in and we'll have some more practice with it. Alright, just some basics. What is a polynomial? It's just a sum of monomials. Okay, mono means one, so one term. Those are some examples up there. Binomials, this is also a polynomial. These all fall under polynomials. Then we have trinomials, 3 terms. Okay, or anything above trinomial is just known as a polynomial. This is the generic form of a polynomial. Okay, this simply means that if I start with something that's x to the 5th power, next one says it's going to be x to the 4th. Then what comes before 4? 3, which is x cubed. What comes before 3 is x squared. Then x to the 1st, and then 0. Okay. Make sure all the coefficients are real numbers. And again, the first term cannot be 0, because then it's not going to be a polynomial. It's going to be something else like a linear function, okay, so on and so forth. Synthetic substitution, okay, this is one of the substitutions that we're going to actually learn. This is going to lead us into synthetic division, which we're going to learn in a couple sections, maybe I think 5.4. Okay. It's just another way to evaluate a polynomial function involving fewer operations than direct substitution. Than direct substitution. Up to this point, all of us have done direct substitution. If I give you a value, okay, or a 0, or a root, okay, or intercepts, these all mean the same thing. We're actually just plugging that number into the function and we're getting some value out. Okay, that's known as direct substitution. Synthetic substitution actually is going to be something new that I'm going to show you in just a moment. Okay, but before we get to synthetic substitution, just let me talk about the type of polynomials. You could have constant, right? It's just a number. That's still a polynomial. The highest coefficient in this problem is a 1, therefore the type of polynomial is linear. Quadratic, because the highest value is a 2, so we're looking at the power, the exponents. That's the reason we covered properties of exponents the first section. Cubic function, that means even though we have a quadratic here, the highest number is 3. Therefore the highest number is 3, therefore we have a cubic function. Okay. Quartic, okay, means that it's a power of 4, okay? And if we do see a 5th power, it's known as quintic. I don't think I get into the 5th root, but if we do, you know it's called quintic. Just let me add that to the list. Quintic. I'll give you an example. I don't know, 4x to the 5th plus 3x cubed minus 20. So the power is 5, therefore the type of polynomial is called quintic. Okay. Alright, these are just type of polynomials. Let's get back to synthetic substitution. What does synthetic substitution even look like? Okay. Alright, here we go. Anytime you're on the outside, you are multiplying. Anytime you're on the inside, you are adding. Okay, what are you adding? Well, we're going to see an example in just a moment. Here, are all the coefficients. Okay, if you got what a coefficient is, well, just look at the examples up here. The coefficient for this, there's the number 1 here. Coefficient for here is 2. For this one, the coefficient for x to the 4th is 3. for x squared is 2. The coefficient here is -5. That's what coefficients mean. Those numbers go up here. X's do not go here. So I don't want to see no x. Okay, so no x is up there. Okay. Simply numbers. Okay, so all the numbers go up there. Whatever you are substituting goes out here. Okay. And again, I'll explain the process as we do an example. Alright, so we're talking about this general form of a polynomial. What the heck is a polynomial? Okay, so a polynomial cannot have radicals. Okay, it can't have any logs. That's called logarithmic function. Okay, no variable in the exponent and no division by x. Some examples. I'll just put them right here. So radical x. Okay. Now, it could have radical 5. This is still a polynomial. Because radical 5 is just a number. Okay? Radical 5 is a constant term. If you plug it into your calculator, it's going to spit out a number. Okay? You can't have radicals, radical x. You can't have no logs. So log x. I know that's kind of hard to see. No variables in the exponent, so I don't know, something like 3 to the power of x. Okay? And you cannot have division by x. So division by x means negative numbers. So 2 to the negative x, which is the same thing as 1 over 2x. Okay? All of those are not polynomials. So these ones right here. Not. This one over here is a polynomial because radical 5 is just a number. Okay. Something important to remember when we're talking about synthetic substitution, your problem has to be in standard form. What does that mean? It means that the highest power has to be first and it has to go in descending order. Okay. So it goes 5, 4, 3, 2, 1, 0. Okay. So largest power first, smallest power last. Okay. Also, we're going to look at some examples where we know and identify what a polynomial is. What is the leading coefficient? What's the constant? What is the degree of the polynomial? Okay. Again, I'm going to give you some examples and then you're going to go ahead and try some on your own. So whether you pause the video, okay, it's up to you. Alright. Make sure to copy down the directions. So decide whether the function is a polynomial function. So we're simply going to look at the problem. Does this look like a polynomial? Okay. If so, write it in standard form and state its degree, type, and leading coefficient. Alright, let's go ahead and do number 1. Again, I'm going to do 2 if time permits. If not, then I'll just do 1 and we'll skip on. First one, h of x. X to the 4th minus 1 to the 4th, x squared plus 3. Okay. So when you're looking for a polynomial, you're looking for whether, do you see radicals? We don't have any radicals. Okay. We don't have any logs. We don't have any division by x, okay? And we don't have any x in the powers, okay? So this is actually a polynomial function. So first question, yes. It's a polynomial. Okay. Second question, if so, write it in standard form. Well, if you look at this, this is actually in standard form. The highest power is 4, then comes 3, which is not there, then comes 2, there is no 1, and then 3 is 0. Okay? Alright. State its degree. So what is the degree of this function? Okay. Remember, degree is the highest power. So the highest power I see a 2 here, but that's not the highest number. The highest number is 4. So degree is 4. Okay? What type is the degree 4? If you look back at your notes, that's called a quartic function or quartic polynomial. Okay. What's the leading coefficient? The leading coefficient is whatever number is in front of your highest power. So the highest power here is 4. The leading coefficient is equal to 1. Okay. For the next example, I'm just going to abbreviate this as LC. What is LC? Leading coefficient. Alright, so I want you to try 2, okay? I want you to try 4. I'm actually going to do number 3. Okay. Alright, g of x is equal to negative 5x plus 6x to the negative 2. Okay. If you look at your examples, okay, of what is not a polynomial, we cannot have a negative exponent, okay? Because if we were to actually rewrite this, this is the same thing as negative 5x plus 6x squared. We cannot have a division by x. Division by x is, it has its own section. That's called rational functions, okay, which we're going to see in the future. So, number 3, not a polynomial, and I want you to give me a reason because we are dividing, that's hard to see, sorry, we are dividing by x. So again, not only do I want you to simply, okay, state that it's not a polynomial, give me an explanation. Okay. All right. So pause the video or do whatever you want. Okay. Go ahead and practice number 2 and number 4. All right. So more practice. Okay. I'm going to go ahead and choose 1. You guys are going to do 3 for homework. Okay. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. Okay. All right. Let's go ahead and do number 5. Okay. If you look at number 5, I'm going to go ahead and rewrite this. Let's do it over here. F of x is equal to 7x minus radical 3 plus pi x squared. Okay. Alright, so first step, is it a polynomial function? This might be tricky because we have a square root, but again, if you punch in square root of 3 into your calculator, it is actually a number. So this is actually a polynomial, so the answer is yes. Put it in a standard form. Standard form. F of x equals pi x squared plus 7x minus radical 3. Okay? Highest power first, lowest power, then the number by itself. Okay? What type is this? But before we get to type, what degree is this? Highest power is 2. Type, that's a quadratic. Leading coefficient, LC, is pi. Okay. Alright, so again, work through problems 1 through 8. They're giving you trouble. That's what I want you to ask when you come in tomorrow.